Network topology, first of all, we have to understand what is network. Network is a simple computer. We are talking about the computer network. So the computer network is when two or more computers are connected together and communicated together for the purpose of the message passing, then it is called as a network. Now we are in this particular, we are going to use the network topology. That what is actually the topology. The network topology defines as a, that is the graphical representation of the network. Network topology, you can say, that is the graphical representation of the nodes or some supporting devices like the printers and other devices, whatever are connected with the system. And network topology describes the layout of the wires and the devices as well as the path of the transmission. So there are different type of topologies are there. There is a bus. There are actually the 5 topologies we are using on the network. Suppose you are connected with a LAN or a MAN or a WAN, whatever the type of network, there is some graphical representation of how these particular systems are connected. So this is the defined by the network topology, such as there is a bus topology, ring, star, and the mesh topology. Now, so you can say in simple language that is what is network topology? That is the arrangement with which computer system or network devices are connected together. So you can say that there is a physical and logical aspect of the network. So network topology is the graphical representation of the nodes in a simple language. The first is the mesh topology. Mesh topology means before starting the mesh topology, we have to understand the dedicated link. The dedicated link is what? Whenever your systems are connected. Suppose that this A and B are going to be connected and this A and B having a dedicated link. This dedicated means what? Dedicated means only one system is connected to the other, not other values. Only one system is connected to the other, so that there is a secure messages will be transferring. Or this link is called the dedicated link, you can say, and there is a communication between these two as a dedicated communication. So in the mesh topology, all the links are or all the cables are like the dedicated links are there. All these systems are connected. So you can say that is in the mesh topology, all nodes present on the network are connected to each other with the cable or a link. This particular cables are there. So if there is a n number of nodes are there on a network, here you can see there is a 5 nodes are there and each of them are connected together. So each of them means if I want to communicate with A to B, C, D or E, if I want to communicate with A to B, directly I can communicate. Or if I want to communicate, there is no inside the any other node is there. So there is a dedicated link present for each and every node present on the network. In this particular scenario, if there are n number of nodes, so in mesh topology, number of cables for implementation of the mesh topology, that is n into n minus 1 by 2. Means what? If there are, I have 10 systems are there. Suppose 10 systems I want to communicate. This particular 10 system means what? Now if the n value is 10, so I needed 10 into 10 minus 1 by 2. That is 55 cables I require. Now in the mesh topology, there is a number of cables are like n into n minus 1 by 2. So now we can understand that how the mesh topology will be connected. So you can see here, there is a A, B, C, D, E is there. All these values are connected with the dedicated link. There is a dedication towards this. Means if there is any network or any node will fail, suppose that this particular node will fail or a damage, is there any effect of the remaining network? No, because all are connected with the dedicated link, so there is no requirement. But if I want to add one other system, I want to add this system in a mesh topology. What will happen? I require, if there is a n, means what? N into n minus 1 by 2. There is a 5. Means what? I needed the 5 cables. 1, 2, 3, 4, 5. I needed this amount of values will require. So the implementation of a new net node will be connected is going to be complex. Otherwise, it is easy. If there is a one particular node will be failed, there is no effect on the network. So you can see here in the mesh topology, if we are talking, if any of the system is connected, suppose these three systems are connected, so each and every node will be connected with the dedicated link, and this link is called as a dedicated link. Link is what? Link is the transmission media. Transmission media, whatever media you are, it can be a guided or a unguided, but the dedicated link, so A, B, C will be connected with all these with a dedicated link. If there is a 3 nodes, so in this example, number of cables required in the n into n minus 1 by 2. That is n into n minus 1 by 2. So you can say 3 into 2 upon 2. So I require the 3 cables to add if there is a different node I want to add in this. Means if I want to add one node system in this particular system, so I needed the 3 cables required. That is, and this is the extra node, and if one node will be failed, what is the effect of this network? There is no effect on that. Each and every remaining part of the nodes will be connected and communicated easily. Now, the main advantages of the mesh topology that it is very robust. But the problems or cons of the mesh topology is that installation and configuration are difficult, which you already see. If I want to need the next system to add on that particular network, it means there is a so many cables required every time. Imagine there is 100 nodes are connected in the mesh topology. It means what? N into 100 into 99 by 2. This much amount of cables I required if I add only one system on that particular network. So that means installation and configuration are very, very difficult. And the cost of cables is high as a bulk wiring is required. It is very, very complex, and the cost of maintenance is also very high. Even though it's advantage because it is very secure and the private, or you can say because there is a dedicated link, only one system is connected to the another. No one other else will be interpreted with this. So that there is it provides the security and privacy, but the problem is that installation and configuration and the cost. So we are going to the star topology. Every time whenever we are switching from one topic to another because of some drawbacks from the previous one, so that we are overcoming of that. So it is just like the drawback of the mesh topology, that is the installation and configuration and the cost, so that these cons will be overcome by the star topology. Now in the star topology, as the name suggests, it is just like the star. There is a hub, and you know that we in my lecture we already discussed about the connecting devices, that is a hub, bridge and switch. Hub is a broadcasting network, you know that, no? Hub is a broadcasting network, means every time whatever packet it has been received, every node present on that particular network, it will broadcast. It is just like if there is a hub is there. Hub is a connecting device of the physical layer. And if the particular so many devices are connected together, if there are 3 devices are there, and the one is the source and other is the destination, this particular packet is governing by the sender. This sender is there, but what will be the responsibility of the hub? To send to the destination, but actually the hub is going on like the broadcaster. Broadcaster means every node present on the network, whatever the nodes are present, hub creates the replica and transmit it in each and every outgoing line of this particular. So this is the hub as a broadcaster. Now, if you're talking about the star topology, in the star topology is what will happen, that is the system 1, 2, 3 and 4 will be present. It means what? There is some nodes are present. It is just described as a star. So fine, if there is if system 2 is a sender and this is the destination, it creates a packet. That first packet is there. This particular packet is going on here. First, it will be going, it is hub like a mediator, goes to the hub, and after that, it will be reached to the destination in the star topology. So, in the star topology, the main advantages of the star topology is if there is a n devices. So, number of cables will be what? You can see here, if there is a one particular node or a hub or a bridge is there and you are connected with this number of values, means these are the nodes are connected. When these nodes are connected at that moment, means what? You can easily calculate if there is a 5 devices are there, means 5 cables required. It means in the star topology, how many cables required? If there is a n nodes, then the cables required are as an n, because the n number of nodes are present. So the n cables required. Now in the bus topology, as you know, that when you are entering the lab, in the lab there is a 2 switches are there in your cabinet, and that particular in the your computer network lab or any lab, every time the bus topology will be implemented there. Now we can discuss the what is bus topology. In the bus topology, as you can see in the star topology, if one particular network or one particular node will be disconnected or damaged, it is okay. Each and every value will be easily configured. But if I needed a one particular system will be connect this, that is also okay. Only one cable required, that is also. But if there is a hub will be damaged, then overall network will be damaged. This is the main drawback of the star topology. Now, in this particular star topology, if the hub is there, then the whole topology will be fail. And the cost of installation is also very high. The main advantage is there, only one port or a one cable required if I needed to add on some devices on the network when we are using to implement the star topology. That is okay. But in the bus topology, whatever drawbacks we can get the star topology, now in the bus topology. In the bus topology, there is a backbone cable is there. That is also a link, but this is called as a backbone, and these are called as a drop lines. And the node 1, 2, 3 is connected. Every time, if the node 1 is suppose this is the sender and this is the receiver, at that this sender will create a packet. This packet will be going on here. Also going to the node 3 also. But in the node 3, when this packet will be here, you already know in the always there is a packet, there is a source address, destination address and message, because the destination address of the node 3 is mismatch. So it will be discarded. Again this packet flows to here. This packet is again there is a mismatch. So this packet is going to be discarded. Now this packet flows to here. You can see this particular packet is going on node by node, each and every node with the help of the backbone line. In the next line, this packet is going out here and accepted because the destination will be match. This is the simple bus topology, but bus topology is very important because all the labs are implemented with the help of the bus topology. The main advantage of the bus topology is there, that is it requires the n plus 1 cable. If any particular node, I want to add some node, it's simple, only one drop line I needed
and I can add this particular node. If any node will fail, suppose node 3 will fail, is there any effect on the network? No, because each and every node will be connected with the backbone. But the main drawback is there, if their backbone will be fail, at that moment, all these particular value will be fail, or all network will be fail. Now the ring topology. Ring topology, as the name suggests, it is like the ring. Ring topology is of two types. First is the unidirectional and the bidirectional. We can see both one by one. First, suppose this particular ring topology is a unidirectional. If it is unidirectional, only one direction the packets will be moving on. In that point, if station 1 is my sender and station 4 is my receiver, that moment station 1 generates a packet. This particular packet is moved here. What will happen in the station 3? This packet will be discarded because why it is discarded? Because the particular destination address will be mismatched. After that, it will be going on here and match. And now, if there is a response is going on, the response is going on like here. If I needed one particular node will be added in this ring topology, I only need the 2 cables. So we can connect with this particular node. That is okay. If one particular value will be damaged, just imagine if one particular node will be damaged, that moment what will happen? The whole particular system will be damaged because the ring will be disconnected. So, in the ring topology, number of cables required, what will be the number of cables required in the ring topology? If there is suppose there is how many cables will be required? That is what? That is n-1 cables will be required. So, we can see simply in the ring topology, there is n-1 cables will be required in the ring topology. And every time the ring topology is the unidirectional or bidirectional. If the ring is connected like this, only moving from the one direction, that is a unidirectional. And if this ring is connected with like this and like this also, then it is called the bidirectional ring. Now in the tree topology is like there is a central hub is connected, and this is, you can say this is called as a root, and other hubs are like the secondary or the child, and these systems are like the leaf node. They are connected like this. If one system is failed, there is no effect on the system, on the network. But if the root will fail, the overall technology, overall network will fail. If I needed one particular systems to be added, that needs only one wire, and I can add the next new system. That is the tree topology. So, number of advantages of the tree topology is allows the more devices to attach to a single central hub. But the problems is that if the central hub, if the secondary hub fail, that is okay. My first value will be connected. That is okay. But if the central hub will be fail, the complete system will fail. So here you can see there is a n devices, one backbone cable when there is a bus topology. In the ring topology, there is a n number of cables required. In the value of maximum connection is reliable, that is, and in the mesh topology, that is n into n-1 by 2 will be required. And in the bus topology, there is a n plus 1 value will be required.